Everyone is building AI agents now, but when it comes to deploy them to production and actually interact with real users, there's a lot of problems that come along. They all sound good on paper. Agents are autonomous, multitasking, and they can execute really complex tasks. But again, when it comes to deploying them to production and actually working with real users, they're either slow, very costly for the cases that they are deployed, and can produce a lot of hallucinations and incorrect answers. And today we're going to show you actually how we're building AI agents that actually work in production for real SaaS companies. I'm Alex, the CTO of Codelevate, and let me show you how we do it. First, let's define what is actually an AI agent. A very overloaded word in today's age. An AI agent system can understand user input, make decisions, interact with tools or data, and complete complex tasks. But here's the thing, the LLM is not the agent. The LLM is only the brain. The tools and systems that we build around the LLM is actually the agent. There's two types of agentic flows, workflow-driven and self-organizing. Workflow-driven agentic flows are usually, as the name suggests, predefined steps that the agent has to execute. This could be a single agent executing multiple tasks, or multiple agents ordered in a specific way based on a business logic that has been defined to complete the task. A workflow-driven agentic system is predefined sub-agents that execute one after each other, where each of them can have a set of tools and context that they need to work on. As is probably clear, use workflow-driven when you know exactly what are the steps that you need to execute, usually in automation processes, and use self-organizing when you don't know exactly what will be the user input. This is perfect for flexible scenarios. So in the end, when we say agent, we're actually talking of a complete ecosystem of how it thinks, acts, and loops. For your agent to be production ready, there's really 5 essential things that you have to think when you're developing your agents or your agent team. The first one is context management. This is one of the most important parts, as in the end, LLMs are trying to predict the best next word when they're generating their output. Providing the right context of the task and actions that needs to be performed by LLM is critical. The context management can also make your LLM process unique based on the uniqueness of your actual data that you have on your platform. So information and context about user profiles, past interactions, relevant documents and metadata, session states. So with the context, the agent can get as much information for the task at hand in order to improve the accuracy and of course improve the final result. The context management is usually obtained via APIs, where we're pulling some information from third party, or actually providing tools to let our AI agents interact with our database. The next essential part is tools. We give access to tools for our agents mainly for 2 reasons. One is to pull information, again, that could be from the database or from third parties, in order to enrich the context of our agents. And the other case is when we want our agents to make actions in the digital world. The tools usually are, like I mentioned, API driven, calling some API of a third platform or actually your platform, having the ability to interact with the databases. Now with the very popular MCP servers, which are most of the time wrappers around APIs of popular platforms, but really speeds up the development. And of course, the uniqueness is that you can build custom tools for your agents very specifically for your SaaS platform or actually for your case. Each of these functions have very clear descriptions of what they do, so the LLM can again understand the context of the tool and know when they have to call it. The third one is actions and safety guards. Not every information that has been asked from the user input should be returned. So that's why it's important to set up guardrails for these LLMs. There's different agent frameworks that really help you to provide the guardrails and the security that you need. However, some of the rules that you always have to follow are: you have to set up confidence thresholds, you have to have manual reviews in some cases, rate limits and action queries, and one of the most important one is output validations, which, as I'm going to share with you, the tool that we use, Pedantic AI, provides an ease of use to implement such a thing, which really streamlines your AI agent and improves the output that is producing and minimizes the errors. The fourth essential part is cost management. Agents need to be affordable and fast. To achieve that, we tracked and optimize token usage and model selection. In almost every case where we're developing, we're always trying to do it with a lower model or a cheaper model first and see what are the results. Very importantly, serverless execution. In many of the cases, these agents are usually woken up for a specific set of time and a specific set of tasks, and then they have to shut down. So using serverless architecture is a perfect match for these cases and can lower your costs significantly since you're paying only for the time of execution. Caching is another way to reduce your costs, especially for your LLM calls. Managing costs and making sure that your costs stay low is a perfect way to introduce more agents into your system and your platforms. And the fifth essential thing is feedback loop. Agents improve by listening. That is why we have to track the usage, the failures, and the errors that potentially can happen during these processes. So having a tool that can monitor your agents and show how they're thinking and why they have made certain action is really critical for improving the process of your AI agent. So now let's talk of actually how we are building AI agents at Codelevate. First, we need to start with defining what type of agent flow we're going to have. As I mentioned, we have two types of agentic systems, a workflow-driven or an agentic system. So the first one that we're going to see is workflow-driven. The user provides an input. The agent, as you can see, is hosted serverless and have access to tools. Usually in a workflow-driven, and actually in most agentic systems, it is recommended the agent to be very specific for the task that they're built for. So in some cases, you can have an agent that is specifically created only to query data and make assumptions about that data, and these assumptions to be passed to the next agent. And the next agent will use these assumptions and based on what their configuration is, perform some additional actions. And in that way, all of the agents and their specialties are executed and passed to the next agent until we reach the output that we desire and send it to the user. So in the workflow-driven system, every step is defined and we know the execution flow and the order the agents will execute, making sure that the output we provide has followed the business logic and workflow that we have done. The other system, as we said, is an agentic system or self-organized system. In this way, again, we are receiving a user input, but then we have one thinking agent. And this thinking agent usually uses a more expensive LLM model or a more smart LLM model. And based on the user input and the prompts and configurations that are passed to this thinking agent, the agent will decide what other sub-agents should be called in order to best achieve the task and input that the user has provided and the configuration that this thinking agent knows. When we are developing the AI agents, especially the thinking agent, we actually have different type of system documentations that the agent has access via the tools to pull in order to know what type of delegations and steps needs to be executed. So in a way, what this thinking agent does is that when they receive the user input, they are setting up the steps that needs to be executed and the workflow that needs to be executed for this agentic system. So in the graph here, what you see is that the thinking agents first decides to delegate to agent number one. That agent number one, again with their specialties, they will run their job and will respond to the thinking agent. And most of the time, the thinking agent knows that once this agent one responds, they need to call agent number two to finish the work and then output. But here you see that maybe you have other agents that are not called for specific inputs. Again, here with the serverless architecture, you're only paying for the agents that are executing, making your flow very cost effective and cost efficient. Each of these agents, like I mentioned, have tools that they can call, and their specialties is based on their configurations and tools that they can access. Now I'm going to present you with the technical stack that we use here at Codelevate to build agents and agentic systems. So here you see the layers that we have set up for having a production-ready agentic flow. First of all, we use the popular cloud providers like Amazon, Microsoft Azure, and Google Cloud Platform for hosting our agents based on our requirements. And because each of them allows us to have the serverless framework that we mentioned earlier. Then, as mentioned in our previous videos, we are using infrastructure as code to orchestrate and create the resources needed to host our agents. This allows us to quickly spin up systems and create resources. And in cases we need to add or adjust different resources within the flow, within the cloud providers, this happens very quickly and very easily. Then, as mentioned, our environment where we're hosting our AI agents is always serverless, so we are only paying for what we use, and it are always written in Python. And they're written in Python because the framework that we have chosen to build AI agents, we use Pydantic AI. Pydantic AI is an incredible framework that you can see how we decided to use it in one of our previous videos, and it provides a lot of the essential benefits that we just mentioned, or the essential points that we need in order to have a production-ready agent framework. What Pydantic AI allows us is to build AI agents quickly, so abstracting all the configurations and logic that you need for building an AI agent system. But also, Pydantic AI allows us to validate the output that the agent provides. In many cases, what you're going to have is that you would need a specific output, usually a JSON or some sort of a specific structure that you need for your platform. You can define that in Pydantic AI, and the framework will instruct the LLM, and it will check if the output, the type of outputs that you have defined, are presented in the output of the LLM. This is a huge improvement and reduces the bugs and errors that your users may experience, because the framework itself validates if the data that the LLM is produced is valid and is based on the criteria that you have provided. With Pydantic, what we also use is Logfire, which is a tool for debugging agents, and it's a tool that really provides all of the details that you need. Then, since we're using Pydantic AI, we are model agnostic. So the models that at this stage we're using is either Cloud, ChatGPT, and Llama for other smaller tasks. So with this technical stack, we have the ability to host our agents on the major platforms and use the established tools that these platforms provide. We manage everything via infrastructure as code, so we're very flexible and fast to deploy. Our environment is cost effective and written in a popular language like Python. We use Pydantic AI, which provides a lot of the tools and benefits that you need in order to develop a production-ready AI agent system. And then we are using the models based on the type of tasks that we're doing and based actually on what our users require. Here I'm going to show you a very basic workflow that we have built for one of our SaaS platforms that demonstrate some of the tools and process that we described earlier. So here in this case, we wanted to automate the onboarding process of a marketplace SaaS platform. What the user can actually do is open a chat widget, and we help them with some predefined prompts. The user can decide and say, set me up, and that is a trigger for the AI agent workflow to start executing the processes and steps for the workflow that we have built for the process set me up. What this process means is we first ask any questions that we have towards the user after the LLM has checked the information provided by the user. The user can also provide website information that we can scrape and also use in our context. So here we enter the access with tools. Once we have all of the context that we need, we move to the next step, which is to call tools or custom functions that we have built for this specific SaaS platform to create the accounts and basic settings automatically applied. Under the hood, what the agent does, it just calls a tool that calls the API towards the SaaS platform, which is the API for creating a user. And since we're using Pydantic, we can define exactly the output that we need, which is needed for the API in order to execute correctly. In this case, we had to provide the standard fields like email and password in order to create the user. Then once this is created, the AI agent already triggers the next step, which is to send an email to the user that has triggered the process with their credentials in order for them to first log in and change their password. But also in the meantime, it is going through the next step, which is to already generate for the created user the services and products that their listing on this marketplace. And all of that information is coming from the context that the user has provided or the context that we have scraped from the website, with additional configuration on how to write services and product descriptions and information. And again, we are validating the output that the LLM is generating because the data that we send to the API has to follow a specific structure. And as mentioned, the agent sends a secure login with a preview link for the provider to see the products that have been created. Then, once the provider and the user is logged in, they can provide reviews and request changes to the LLM via the chat functionality until they're satisfied. So as you can see in this workflow, we are utilizing all of the concepts that were shared before. We are setting up context. We are utilizing tools either to connect to third parties to extract more context, or we have tools that perform custom logic and actions with the SaaS product marketplace here. And we provide tools to allow the agents to interact with the marketplace platform. And then we utilize the output validation via Pydantic to make sure that the APIs and tools that we're calling have the necessary data in order to execute correctly. And all of this is completely set up serverless, so each step is executed and then you pay only for the execution time. And all of it is monitored and managed by Logfire. So in case of issues or errors, we can easily see what has happened and make changes so it doesn't happen again. AI agents are possibly the future of SaaS, but only if they are reliable. Reliability doesn't come from more smarter or costly LLM models. They come from setting up the proper structure around the LLM to ensure the outcome that you desire. If you're building any type of AI products, follow this principle to have a successful deployment to your production environment. You can of course also reach out to us so we can help you with defining your AI agents and help you apply the principles and more that we shared here. Thank you for watching, and I hope now you have a better understanding of how to ship production-ready AI agent systems.